Hello everybody, my name is Mike Gag, and in this video we are going to look at creating bitmaps in Allegro 5. Now if you had read part 6.0 that I had posted, you would know that in Allegro we can basically call any flat image that is static a bitmap. Alright, so in Allegro if we upload a JPEG or actual bitmap file or a PNG, those are all considered inside of Allegro to be bitmaps, just maps of bits or arrays of graphical data. So knowing that information, we can create inside our programs our own bitmaps to use. And we're going to go ahead and do that in this video. What I have here as far as the code goes is the Allegro.h, the Allegro primitive library, just creating my done variable, my width, my height. I'm just initializing some of the add-ons we've seen before, basically just creating a very basic game loop with the escape key getting us out of the game, and then that is it. So that when we run this, all we get is a black screen here that doesn't do anything until I hit escape, in which case it exits. Alright, so basically anytime we work with visual data inside of Allegro, we're going to store that data inside of an Allegro bitmap variable type, and that's a new variable type. It's not one we've seen before. So up here under my Allegro variables, I'm going to go ahead and add one. It's got to be an Allegro bitmap pointer, and I'm going to call it image, set equal to null. And this is just going to be a variable that is going to store image data for us. And we're going to see here later that we've actually been working with bitmaps all along, and we haven't really noticed it. Alright, great. So now that we have a bitmap image created, we can begin working with it. Currently, the image that we created, this Allegro bitmap named image, is blank. There's no data to it whatsoever. But we can draw on this image as the same as we would draw on the screen, and then use that image over and over and over again. So thus creating our own image inside of our program. And what I'm going to do is, if you remember back to part 5 in our video game, we created that spaceship, and basically every cycle that spaceship got redrawn onto the back buffer. And to draw that spaceship, it was actually 3 rectangles making up the body and a triangle. So I had to draw 4 different unique primitives every single cycle to make that work. So we are going to instead draw it once to our image variable, and then just draw that single image variable to the screen every single cycle. Alright, so let's see how we do that. First thing I want to do is I want to record a variable that's going to be the dimensions of my image. The only reason I'm doing this is to make the translation from the way we used to draw the spaceship to the way we're going to draw the spaceship much simpler. In real programming practice, you may not do this because you may not need to do this. Like I said, I'm just trying to do the easiest transition possible. So we're going to come up here to our variables. We're going to add a new one. We're going to call that int image rad, alright, equals 20. And basically, the way I envision this variable is to be the radius of our image. Granted, our image is a rectangle, not a circle, but basically I want to be able to find the center of that image and draw everything in relation to the center of the image. So I'm going to go ahead and specify that as 20. So my total image will be 40 by 40. Now that we know the dimensions of our image, we can go ahead and actually create it. So far, we've only created a variable to hold it. So now let's actually create our image. I'm going to come down here after I do my add-on initialization, and I'm going to say image equals al create bitmap. Alright, and it just wants a width and a height. So I'm going to do image rad times 2, image rad times 2, my width and my height. So great. It is now creating for me a 40 by 40 bitmap that now we have in memory and we can draw to whenever we want. Now, to draw to a bitmap in Allegro, we have to basically tell Allegro, hey, we're not going to be drawing to the screen for a little while. Basically, the screen is a bitmap. The back buffer is a bitmap, right? It's just a bitmap that we've never seen. It's part of the display. And every time we draw to that bitmap, and that bitmap gets drawn to the screen. Every time we go ahead and type or flip display, it takes that back buffer, brings it to the front, and draws it to the screen. So we have been working with bitmaps all along, we just haven't really noticed it. So what we have to say is, Allegro, we need to draw to a different bitmap. And that different bitmap for us is going to be al set target bitmap. And we're going to say image. So now all of our drawing functions are going to draw to image instead of our screen. Alright, so now that we're prepared to draw to the screen, let's go ahead and I'm going to copy and paste some code. And it's going to look real familiar to you here real quick. Right after I go ahead and tell Allegro that I'm going to be drawing to this bitmap, I'm going to paste some code right here. You all should probably recognize that. That is the code to draw our spaceship from the game we saw in part 5. Now, granted, here we're talking about ship X and ship Y, so we're going to need to replace those variables. And that's the reason I created this image rad variable, so that I knew the exact center of my image, so that I could go ahead and just do a quick and easy swap, right? I'm just going to replace all these ship X's and ship Y's with the image rad variable, and everything will continue to work flawlessly. Now, in a different scenario, that wouldn't work. That's why I'm using this in a very specific situation. So I'm actually going to use Visual Studio's built-in tool to handle this. I'm going to come up to Edit, I'm going to do Find Replace, and I'm going to do Quick Replace. And this window will pop up, and I'm going to type ship.x, and I'm going to replace it with image rad. I do Find Next, Replace, 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 so on and so forth as it replaces all of these for me. Perfect. And then I'm going to do the same thing with ship.y. Perfect. Okay. So, basically what we know is this, is we're telling Allegro, hey, we're drawing everything now to this image. Now, our drawing functions, our AL draw filled rectangle, doesn't change at all. We don't have to specify where we're drawing it. Allegro keeps track of that for us. Allegro knows we're not drawing to the back buffer, we're drawing to image. So all of these function calls to draw our primitives are being drawn directly on image. Of course, when we're done drawing to image, we have to tell Allegro, okay Allegro, now it's time to go back to drawing to our back buffer. And so we do that by saying AL set target bitmap. And remember, like I said, we've been using bitmaps all along. We do AL get back buffer, and we pass in display, signifying that display actually holds a bitmap in the background that we can set as our target. So there we go. Now, all said and done, what's going to happen is when this program starts up, it's going to create a bitmap named image. It is going to draw our spaceship to it, and then it is going to set its target back to the back buffer, which is all well and good. But at this point, it's still not going to show up. We need one more step. And our step is to actually draw our bitmap to the screen. And we do that with the AL draw bitmap function, which goes like this. First thing we need to do is we need to type in the bitmap we want. Next, we type the X and Y coordinates. I'm just going to do width divided by 2, height divided by 2, and then any image flags, alright, if we want to treat our bitmaps any special way. In this case, we don't. Alright, so that's it. So basically, inside of our game loop, you can see how much simpler it is to draw our spaceship now. Our spaceship is now a single line of simple code, as opposed to constantly mapping out and drawing these primitives. Alright, so you can kind of get the idea in your head that it's much more efficient to use this bitmap. Because we draw it once, and then we just keep blitting it, which stands for bit block transfer. That's a term, blitting. Blitting it to the screen. And it ends up being a lot faster because we no longer have to do our color calculations, we no longer have to do any math. It never has to figure out how to set up our rectangles and things like that. It already did that, and now it's just quickly transferring one bitmap data to another bitmap data. And we'll go ahead and run this. Now, of course, we see our black screen to begin with, and that's because we're not using a timer or anything. If you remember back to before we did the timing in part 3, all of our games were like that. But as soon as I hit a key, it fires off an event, and then now we can see our ship. So our ship looks just like it did in the first game, though now every single cycle is just blitting that bitmap. So this in and of itself is its own bitmap. And if you don't believe me, I can go ahead and prove it. What I'm going to do is I'm going to come up here to right after we set our target bitmap image, and I'm going to do AL clear to color. The reason I'm going to do that is I'm going to color with an R, is I'm going to color this bitmap a certain image so that you can see the size of the bitmap. So you see that it's actually a solid square bitmap as opposed to just these primitives being drawn. So I will set it to ALMap RGB. Let's do, I'm going to pick a random one here, 127, 127, 127, which will be gray. There we go. So now, when I run this, you will see the confines of the bitmap we've created. It's an actual bitmap. It's a picture. I could save that if I want. And a matter of fact, in future videos, we are going to learn how to save bitmaps out of our game, which is actually kind of cool because then you can do screenshots and neat things like that. But for now, that is how you create and draw to a bitmap inside of Allegro. And in future videos, we're going to look at loading pre-drawn bitmaps into our game.